Hello, this is Mr. Kinyanola, and I'm going to show you why the area of a kite, the number of squares that fit inside a specific kite, is the formula of d1 times d2 over 2, or diagonal 1 times diagonal 2 cut in half. Now, I had in another video how to get this formula by performing some surgery, by moving certain parts of the kite around to get a rectangle. I'll put a link to that video in the description. This one is a more technical way of getting this formula, more formal way to get this formula using the power of algebra and substitution. So let's go right at it. So a couple of things we need to remember. The area of a triangle is base times height divided by 2. So the area of a triangle is base times height divided by 2 because a triangle is just half of a rectangle. Next thing that we need to remember, let's look at this kite right here. I labeled parts of the kite, and if you want to know more specifics about a kite, look at my previous video, which I will also put in the description. So a kite is just two isosceles triangles. So here's one isosceles triangle on top of another isosceles triangle. So this side is congruent to this side, and this side is congruent to this side. All right, so and also the inside of a kite is made by diagonals. We're going to call this diagonal. So a diagonal just connects two opposite points of a quadrilateral or any other shape. So this right here, AC, we're going to call this D1 or diagonal 1. And this part right here, we're going to call BD as diagonal 2. And just so that we remember those parts, we're going to write it over here. So I'm going to call diagonal 1, and diagonal 1 is going to represent A all the way to C. So the length from A all the way to C. And I'm going to remember diagonal 2 right here is B all the way to D. So the measurement from B all the way to D. And just as a little side note, I'm just going to put BD is also, when you add this piece, BE, and ED together. So this piece plus this piece makes BD, and BD represents the second diagonal in this kite. All right, so let's get right at it. So we're going to, two parts of a kite, if we divide it into two parts, is this isosceles triangle with this isosceles triangle. And the concept of, if we can get the area of this isosceles triangle and add it to the area of this isosceles triangle, we will get the full area, the number of squares that fit inside this entire kite. So let's do it. All right, so let's write the area. And let's zoom in just a little for you guys. So the area of triangle ABC is, so remember, the area of a triangle is the base. So the base, which is AC, times its height times the side that is perpendicular to the base. And we know kites, their diagonals are perpendicular. So AC times BE divided by 2. Because a triangle is half the area of a rectangle if we drew that rectangle. So we cut it in half. Next thing is, in our proof, in our derivation, is the area of triangle ACD right here. So triangle ACD is AC, so this is going to be our base, AC, times the side that is perpendicular to it in that triangle, times ED over 2. So here's the area of this triangle inside our kite. AC base times height, that's perpendicular to this base, so AC times ED over 2. Now let's represent the full area of our kite. Let's take triangle ACD plus triangle ABC, and that would add up to, so this triangle plus this triangle would make the area of kite ABCD. ABCD. Okay, so here's the concept. If we have the area of this triangle added to the area of this triangle, we have the full area, how many squares fit inside the full kite. Alright, so now let's do the power of substitution. Okay, so triangle ACD. Oh, actually, let's start. Yeah, triangle ACD is this. We just said that. So I'm going to substitute this with its area, AC times ED over 2. So we stated that triangle ACD is equal to this right here. So we're just substituting into here. And then plus triangle ABC, which is what we stated here, which is AC times BE over 2, which is the full area of the kite. Okay, now let's zoom in a little so that's not too small for you guys. So what we did so far, we took ACD, substituted it with that because that's ACD. We took ABC, we substituted it with this because ABC is AC times BE over 2. So a little substitution. Things are equal, they look different, but they're still equal. Like 4 quarters is the same value as a dollar bill. They look different, but they're the same value. Okay, so we have the area of a kite. Now we're gonna combine these. We're gonna make this look a little, simplify it just a little. If you notice, these two fractions both have 2 over it, so we're gonna put it together. We're gonna put AC times ED plus AC times BE all over 2. Okay, so because they have the same denominator, we could put them both numerators over the same denominator. And then some algebra. What do we notice about these two terms right here? They both have AC in them, so we can factor the AC out. So I'm going to take AC, so factor out the AC from both of these terms, and we're just left with ED plus BE over 2. Okay, so next I'm going to, because I did it in a different order, I'm just going to switch these around. Okay, we can do that with addition. So I'm going to put AC times BE plus ED over 2. The reason why I switched those around, let's zoom back and let's look back at what we wrote at the close to the very beginning. Here is BE and BE plus ED, and if we go all the way back, let's not write over stuff right here, BE plus ED. Oh, look at that, BE plus ED. When we have things in our proof, we could look back at what we've stated, some facts that we've stated in the beginning. We can substitute. So BE plus ED is equal to BD. So let's substitute it, which is equal to AC times BD over 2. Okay. And then let's zoom out one last time. And if we remember, we have AC times BD over 2. If we do remember, look at that. AC is equal to diagonal 1. And BD, hope you guys appreciate my sound effects. BD is equal to diagonal 2 right there. AC is diagonal 1, BD is diagonal 2. Also, we wrote that in our diagram. AC is diagonal 1 and BD is diagonal 2. So we can do some substitution. Instead of AC, we could substitute AC as we stated with diagonal 1. And we could substitute BD with diagonal 2. And we divide it in half. And that, my friends, is how we derive algebraically the formula for the area of a kite. What? So here is all of our great work. Let's see if I could fit all of this in there. So there is that. There is that. And there is that. It works out. All right. So we use the power of the area of a triangle, and we use the power of substitution to get this technical, formal derivation of getting the area, the number of squares that fit inside of a kite, to be the diagonal 1 times diagonal 2 cut in half. All right. I hope this worked out for you. Have a great day.